So here we're demonstrating three-phase transmission line fault identification along with controlling. So the controlling, we are going to making use of relays to disable the so-called phases whenever the particular phase consists of the error. So here we are going to identify the faults like line to line faults with help of this circuit board, current sensing circuit board, and line to ground with help of this circuit board, and open circuits for each phases. So here RYB open circuit faults, and same RYB line to line faults at 2 kilometers 4 6 EH, and R2 grounds, nothing but line to ground faults, so like 2 4 6 EH, and also parallelly line to line, so line faults and line ground faults. So LLG faults also we are going to identify that, and the total interfacing these current sensing circuits to the Arduino Uno board. The interfacing pins are, so line to line fault circuit board interfaced at A0, A1, A2 pins, and line to ground at A2, A3, A3, A4, A5 pins, A0, A1, A2, A3, A4, A5 pins, and open circuit pins are connected at 8, 9, 10 pins, and the 3 relays to control the RYB loads whenever the fault is occurring. Then these 3 relays interface to the 1, 11, 12 pins, and 13th pin to the buzzer board. So whenever the fault occurred, then the buzzer will be indicated. So this buzzer board consists of one transistor to enable this. So here we are using as a transistor as a switch here to on and off this buzzer, and this is the regular power supply board, so which will take 230 volts input from this one. So here we are converting single phase to 3 phase for presenting purpose. So this regular power supply board will take 230 volts inputs and provide us the 5 volts regular power supply, which is sufficient to control all the input and output modules along with our Arduino Uno board. And the 230 volts input to this one parallelly distributed to the 3 loads with help of the 3 electromagnetic relays. So coming to the relay board, so each relay board consists of one transistor, one red LED indication, and 2 resistors and one diode. So the 2 resistors are one resistor for current limiting for the one LED, and a resistor, one more resistor for the BC547 trigger gate purpose, and next one more diode is there. So the diode purpose is freewheeling diode. So whenever we are controlling this relay, then the relay will provide us a back EMF. So it will acting as a flyback diode, so it will neutralize the back EMF from this relay circuit board. And this one is the breadboard, so to distribute the 5 volts power supply to this all the boards. So here we distribute the 5 volts power supply. So here generally, so we are making a fault for line to line nothing but 440 volts, line to ground nothing but 230 volts. So our microcontrollers Arduino Uno board can't measure the 230 volts. So we are going to step down that and converting AC to DC and DC to pure DC, and then regulating that. So then parallelly we are measuring the 5 volts, as controller can measure up to 5 volts only. So coming to this board explanation, there we connected the 4 10 kilo ohm resistors and 1 10 kilo ohm resistor for each phase. So here also each phase. So whenever we are pressing this, whenever the short circuit happens, so then the 10 kilo ohm is remaining 30 kilo ohm, mean nothing but 10 is to 3. So if it press this one, 20 is to 20, and this one is 30 is to 10. So this is going to be the 10 is to 0. So like that, the difference resistance will drop the voltage. The concept of is called potential divider circuits. So then the voltage will be drops, the particular voltage measured by the Uno board, and particular distance will get the certain voltage for each phases. So that the voltage will be converted into the distance. So in real time, this 10 kilo ohm nothing but we are pricing a 10 kilometers of wire, or 2 kilometers of wire. So 2 kilometers. So we know that the length of the wire is proportional to the resistance of the particular wire. So when the length is increasing, resistance increases. Whenever the short circuit happens, so then we can get the less voltage regarding the length of the wire. So coming to the same line to ground also, same concept. And next coming to the open circuitry, so we are continuously checking the continuity on each phase. So whenever we are getting the low voltage or 0 voltage, so it will intimate it as a like open circuit in particular phase or YB phases. So this is the flow of each and every component explanation, and this one is the LCD continuously showing the status of the either fault or status is normal. So let us see demonstration. So initially the buzzer will be on and off 2 times along with LED indication on this Uno board. So now the status is normal as of now. so that the three loads are in on state only. So let us make the error for. So there will get the message on the LCD screen is B are false. That's why the two loads are disconnected. So if Y ground again. So Y ground fault, that is kilometers. So once the device power supply is disconnected, then in order to resume the power supply to that, manually we need to check the status and then we need to reset the system. So this is the reset switch. So once you reset that, it will switch off the three phases again and check for the faults. If there is no fault again, so it will switch on the power supply to the phases. So let us check the line to line LLL fault. So I am pressing the three switches at a time. Then we get the message of RY, YB, BR faults at 8 kilometers. So now going to the fault for LLG. So there will be the YB and B. So that's why Y and B bulbs got switched off. If again red phase ground fault at 6 kilometers. Right, coming to the open circuits. So the state is normal. Open for red, Y phase and B phase. So once the status is normal, then only buzzer will be off. Instead of switching on the loads, only the buzzer indication will be stops beeping. Right, as indication there is no fault. So but it won't resume the power supply to the loads, as we need to check manually again, as the total lines are passing with high loads like 440 volts line to line. So then again we need to reset the system. Right.